All right, we're moving on to part 2 of 1.6. We're going to continue to do descriptive statistics. So we're still going to have a whole bunch of data given to us, and our goal will be to summarize that data. However, now we're going to do it differently. In part 1, we use numeric measures to summarize the data. We learn things like mean and median and mode, standard deviation, interquartile range, those types of things. And they helped us to describe the data by using a number or several numbers. What we're going to do in part 2 here is instead of describing our data with numbers, we're going to describe our data with pictures. We're going to draw plots. And we're going to learn several different types of plots. And in this video, the type that I want to talk about is a histogram. So this is 1.6 part 2, where we're doing descriptive statistics. Step 3 in our 4-step process. Can't talk and write at the same time, apparently. Except now we're doing it with pictures, with statistical plots. And in this video, I'm going to talk about probably the most common form, I don't know, that's kind of subjective, of statistical plot. It's called a histogram. And you might already be familiar with the histogram, but maybe I can refresh a couple ideas. And I'm going to tell you how I would like you to make histograms in this class. And what's going to end up happening is I want you to be able to make them on your calculator. So I'm going to go through an example. We'll do it by hand. We'll do it with the calculator, and then we'll be all done. To make a histogram, we're going to need some data. What I have noticed since I've been making these videos is that apparently I say and words, non-words like that a lot. I don't know if it's just when I'm making these videos or if I say it all the time, but now that I've noticed it, I can't stop seeing it and hearing it, and every time I do it, it makes me cringe a little bit. Suppose I was interested in studying that. How often I say, I don't know, non-words. Like when I'm talking. And I don't know, maybe per hour is what I'm interested in. Well, this is going to be a hard thing to study, right? Because I talk a lot. I've been alive for lots of hours. I guess the population would be all of the hours of my entire life, or maybe my adult life or something like that. I don't know. All the hours when I'm talking, perhaps. There we go. But that's going to be difficult. That's too large of a population. That's not something I can measure directly. Maybe I could randomly select, I don't know, like 10 or 15 hours and have somebody track how often I say, while I'm talking during those 15 hours. That's what I'm going to pretend happens. I'm going to make up a data set here with, I don't know, 10 or 15 observations. And what they will each represent is the number of times I say non-words like, per hour for 15 randomly selected, whatever that means, hours of my life. So maybe the first hour that somebody tracked, I said it 5 times. And then 6 times, and 6 times, and 7, and 8. Let's see, there's 5 observations. And then 10, and 11, and 12, and 14, and 16. There's 10. Let's add a few more. 18, 25, 38, and 49 for my beloved San Francisco 49ers. Let's pretend that this is the data that we have. 14 observations this time. And we want to summarize this data. Well, we already know a lot of ways to summarize this data, a lot of numeric measures from 1.6 part 1. But maybe you don't want a numeric measure. Maybe you want a picture. Maybe a numeric measure is too incomplete. You don't just want to know aspects of this data. You really want a picture of the entire set of data. Well, one way you could do that is by creating a histogram. And what a histogram looks like, I guess I don't have to write histogram again because I wrote it right here. It's a 2-dimensional plot. You have an x-axis, that's this vertical axis here, and a y-axis here. And what you put on your y-axis is the count or frequency of your observations. So what you do is you look at your observations and you sort them into buckets or bins. So for example, I might want to track, I don't know, from 0 to 10, say. So I want to track all the observations in my data set that are in between 0 and 10. And why 0 and 10? That's arbitrary. You get to choose that, or I'll choose it for you. I'll say make your lowest bin contain observations between 0 to 10. If the first one goes from 0 to 10, the next one will go from 10 to 20. And then the next one will go from 20 to 30. And then 30 to 40, and 40 to 50, and so on. And in this case, I could quit when I got up to 50 because my largest observation here is 49. So that way I'd include all of my observations. And then all you do is you just go through and you count. So you're like 5, that would be between 0 and 10. So that counts. There's 1, 2, 3, 4, 5. And then you get to this observation. You're like, ooh, should I count that or not? Like, is that in between 0 and 10? Or is that in between 10 and 20? You can kind of make an argument either way, that it should be included in this bucket or bin, or that it should be included in this bucket or bin. But that's problematic, right? I don't want different people making histograms, having them look different. I want there to be one correct answer. So what are we going to do? What we're going to do in this class is this will always be included in the next bin up. So your smallest bin from 0 to 10 here, this bin really represents observations that are at least 0, but less than, strictly less than, not less than or equal to, but strictly less than 10. And for that reason, we would not include this 10 in this first bucket. There'd only be 5 observations in this first bucket. So I don't know, maybe there's 1, 2, 3, 4, 5. 5 observations in this first bucket. This first bar is going to have a height of 5. And I go to my next bucket. 10, 11, 12, and 14 would all go in that, up to 20. 1, 2, 3, 4, 5, 6. I'd have 6 observations. I already did a bad job here. It should go higher because I'm going to need my next bin to have a height of 6. Because 6 of my observations fall between 10 and 20, or technically they are greater than or equal to 10, but strictly less than 20. So I'm including this 10 in this second group. I don't know, this one, this one, this one, this one, this one, and this one, those 6. What about 20 to 30? Well, there's just this 25 observation, so the height of this bar should just be 1 here. What about 30 to 40? I don't know, I'm running out of symbols here. 30 to 40 would just be this 38 here, so that also has a height of 1. And then 40 to 50 would be this guy here. This is unnecessary. This 49. And there's my histogram. You're like, yeah, I've actually seen those before. We called them bar graphs. This isn't quite a bar graph. Typically, a bar graph is when your data is categorical, not numeric like we have here. Typically, when you're making a bar graph, the different bars don't touch each other. That's the standard anyways. When you're making a histogram, you do want the bars to touch each other. The x-axis is ordered in an increasing fashion like you see here. With bar graphs, it might be like people with brown hair, people with, I was going to say blue hair, that doesn't make sense, blonde hair, red hair, etc. And there's no order necessarily that those have to be in. But if your data is numeric like that, then you're going to increase as you go to the right. Typically, you label your axes. So either down here, you could say this is number of non-words, or you can put that up in the title here, number of us. I don't know, whatever, per hour, or whatever your plot is about. And maybe I didn't teach you a whole lot. Maybe you're already familiar with that, but maybe something that I can teach you is how to make these on your calculator. And it'll be more important than you think to make these on your calculator. And I 100% am going to ask you to make one on your calculator for the midterm. And you're like, how are you going to know if I make it on your calculator? I'll show you how I'm going to know whether or not you made it on your calculator. You'll have to be able to make these on your calculator for the midterm. The reason why is it's what I'm supposed to teach you in this class. I'm supposed to teach you how to make one on your calculator because in theory, you're going to be doing this not with 14 observations, but with, 140. If you have 140, you might not want to draw them by hand. And also, this 0 to 10 as my first bucket, that was kind of arbitrary. Maybe after I made this, I decided that was a bad idea. And my first bucket should have gone from 2 to 7, maybe. And then the next one from 7 to 12. And then 12 to 17, and so on. If I want to change my bins down here, these different buckets in which I'm organizing my data, if I do this by hand, I have to redraw the entire thing. But if I made it on my calculator, it's easy. You just press one button, change one thing, and you're done. So what I want to show you is how to produce a histogram. I'm going to make this exact same histogram on a calculator. It's going to be a 3-step process. And it turns out that anytime you make a plot in this class, it'll be a 3-step process. Your first step is something you already know how to do. Is enter your data. Right, that kind of makes sense. If you're going to ask your calculator to make a histogram for this data, you better tell your calculator this data. As a reminder, you do that under the stat menu. And then you go into the edit column. And you put your data in a list. You could overwrite L1 or L2. We're probably done with that data. But just in case I want to reference it again, I'm going to move this over to L3. And I'm going to type in all these observations. 5, 6, 6. If you want to follow along, feel free. But no pressure if you don't want to. Actually, I'll pause this video while I type in this data. All right, so now I have all my data in a list here. I put it in L3. You might want to make note that that's where you put your data. That's the end of step 1. Step 2 is you have to program the stat plot. Program, sure, the stat plot. What do I mean by that? Your calculator can make a lot of different plots for you. You got to tell it which one you want. You want a histogram. How do you do that? You might guess that it would be under the stat menu, but it's actually not. There's a separate menu for the plots that you're using. It's called stat plot, and it's located up here above the y equals key. So because it's up above the y equals key, I can just hit second and then y equals to jump into that menu. Note, I don't have to save my data or quit out of here. If you do want to get out of this just to get back to the normal functions of your calculator, you can just hit the quit button, which is above mode. So second and then mode would quit. But that just gets you back to the normal screen. You don't have to do that. You could just jump all the way to stat plots, which is where you want to be. And if you go into stat plots, you'll likely see something that looks like this. Your calculator can do 3 different stat plots at a time. In this class, we'll never do more than 1 at a time. So if number 2 or number 3 in your calculator currently says on, you probably want to turn it off, because what we'll do is we'll program number 1 to make our stat plot. So if your number 2 said on, you could go into number 2 and turn it off. Go over to off and hit enter. But mine was already off, so I didn't need to do that. But now this one's off. How do you get back to the last screen? Second and then y equals get you back into the stat plot menu. Make sure number 2 and number 3 are off, and then go into number 1. Number 1 on my calculator is currently off. I don't want it off, I want it on, because I want it to make a histogram. So I put on. The next question it asks me is, all right, what type of statistical plot would you want? Your calculator can make 6 different types of statistical plots. We're going to learn 4 of them in this class, 2 of them in this section. The one you want is the icon that kind of sort of looks like a histogram. It's this third one over here. Let's go over and select this third one. Note that when you hit enter on this one, it'll change what it's asking you. It's currently asking me the questions for this first type that we'll learn later is called a scatter plot. But when I ask it for a histogram, it'll change what it's asking me because it needs different information for a histogram. What it needs for my histogram is really just where's your data. X list means in what list did you put the observations that you want me, your calculator, to make a histogram out of. Mine's in L3. So I hit second and 3 to get L3. If yours is in a different list, tell it a different list. Note that it also says that I can use a frequency list if I want. As I mentioned, we'll never use one in this class. So leave this as whatever your calculator defaults on. 1, or it's just completely blank, or maybe it's an N. Whatever your calculator says, just leave that alone. We'll never use a frequency list. That's the end of step 2. Step 3 is you have to zoom / program window. What am I talking about there? You have to tell your calculator what you want to see. And the way you tell your calculator what you want to see is either by zooming or by programming the window. Depending on the stat plot you're making, sometimes you can just let the calculator guess. There's a feature in your calculator where it'll just guess what window you want to see. There's a zoom stat feature that we'll learn later that sometimes is sufficient. With the histogram, it's not. With the histogram, you cannot use that zoom stat feature. In fact, in every other statistical plot in this class, you'll be able to use the zoom stat feature and you'll be happy with that. But with the histogram, you got to do a little bit more. You got to program the window. So what I have to do is go into the window menu on my calculator. Note that that's this button. It says window right here, but don't press it now. Because if you press it now, if you look up at my cursor, you might notice that it's blinking with a little A on there. What that means is alpha lock is on. On this row, the calculator is expecting something in text. So alpha comes on right now. So if I hit this window button, it won't be like I'm hitting the window button. It'll be like I'm pressing F2, alpha, and then window. So it'll bring me into something different than what I want. I have to make it so it's not blinking with an A in there. So if you hit alpha again, it should blink just like a normal cursor. Another way to get it to blink just like a normal cursor is to just scroll up onto a line on which it's not expecting text. Note that it's blinking like a normal cursor there, but with alpha lock on there. One way or another, turn alpha lock off and then hit window, and you can program your window. So when you're making a histogram, you have to program your window. And the way I'm going to test you on this on your midterm, and I promise you I'll do this, is I'll ask you to sketch a histogram like this. And you'll be like, yeah, I can do that without my calculator. And then I'll be like, to prove that you did it with your calculator, tell me what you put into the window screen. So what I got to tell you is what values go in here for X min, X max, X scale, Y min, Y max, and Y scale. Everything below Y scale, you can just leave that alone. X min is always going to be the left endpoint of your smallest bin. What do I mean by that? I mean, if you look at your x-axis here, my smallest bin is the one goes from 0 to 10. And the left endpoint of that is this 0 right here. Right? The smallest bin goes from 0 to 10. The right endpoint is 10. The left endpoint is 0. My x minimum is going to be 0. The left endpoint of my smallest bin. Then it asks for my x maximum. What that is the right endpoint, but not of my smallest bin, of my largest bin. So my largest bin goes from 40 to 50. The right endpoint here would be 50. That's my x max. Right endpoint of largest bin. For what it's worth, what I'm going to do when I test you on this is I'm going to say make a histogram and have your smallest bin represent observations that are at least 0 but less than 10. This is the text that I will give you. So you'll have your observations here and you'll have that line of text. And from that, you have to figure out that x min is 0 and x max is 50. And for what it's worth, a lot of students put in x max is 10 and then things don't work out and they don't get a histogram and they can't get the credit for this. X min is 0. X max is 50 because my largest observation is 49, so my largest bin will go from 40 to 50. And then X scale is the width of your bins. So note this is going to be specified for you as well. When I tell you that your smallest bin should contain observations that go from 0 to 10, I'm telling you your smallest bin has a width of 10. Right? 10 minus 0 gives you 10. This width is 10 right here. And a property of histograms is that all of your bins have to have the same width. So if the smallest one goes from 0 to 10, the next one can't go from 10 to 18. It's got to go from 10 to 20. They all have to have a width of 10. That common width is what's called the X scale, 10 in this example. Then it asks you for Y values. The Y values are just talking about this axis right here. So in my picture, my smallest Y value is the number 0. And my largest Y value, it looks like it goes up to the number 6 here. And I'm counting up and down by ones between here on my Y-axis. So I would put in 0, 6, and 1. For what it's worth, if you want, in this class, you can always make your Y min 0, your Y max 10, and your Y scale 1. And that's because I will never give you so many observations that you will have more than 10 in a given bin. So your Y max can be bigger than 6. Like it's okay if I show my window screen all the way up here till 10. Just don't make it so huge. Don't make it 1,000 because if the window goes all the way up to 1,000, these will all be scrunched down at the bottom. You won't be able to see them. In order to make this exact picture that you see here, I'm going to have my Y max be 6. But I'm telling you that it will always be okay, maybe in this class, 0, 10, 1 is always okay for Y min, Y max, and Y scale. But yeah, you don't have to do that. And think like if this were not in this class and you had 1,000 observations, right? You might have 301 of your buckets. Well, then you want your Y max to be at least 300, maybe like 400 or something. And you wouldn't want to count up by ones over here. You wouldn't be able to see them. Maybe you'd count up by 100s. So in that instance, your Y min might be 0 and your Y max might be like 400. And maybe your Y scale is 50 or 100. But again, for this class, 0, 10, and 1 will be totally fine. 0, 6, and 1 is also totally fine in this example. Just make sure that you can see the tops of your bins. That's it. That's how you program the window. That's your third step. When you're done When you're done programming the window, just hit the graph key. And if all went well, you'll be able to see a histogram. There it is. And look, that looks a lot like this histogram, right? And we created what we were supposed to. If this were a test, you could sketch this down on a piece of paper and you'd be done. And while I'm here, if this were a test and you were trying to sketch this on a piece of paper, we can just kind of look at it and tell, oh yeah, this one has a height of 5 and 6. But maybe if you had a ton of observations, it would be hard to tell that this one has a height of 285, right, if that were the case. A feature that you'll never need to use, but it's kind of convenient, is the trace feature. When you're looking at a graph like this, if you hit trace, what it'll do is kind of talk you through the important characteristics of whatever graph you have. So note that when I hit trace, my little cursor moved up here. And what it's telling me is this first bin contains observations that are between 0 and 10, technically less than 10. So the 10 does not get included in that first bucket. Remember this 10 right here went into my second bucket. And it's telling me there are 5 such observations. In other words, the height of this guy is 5. And if I press the right arrow key, cursor jumps up here, says between 10 and 20, there's 6 observations. And between 20 and 30, there's 1 observation. And between 30 and 40, there's 1. And between 40 and 50, there's 1. And you never need to use that, but it's just a convenient feature. It's up here under trace. If you now wanted to, if you're like, oh, I didn't like that one, this doesn't give me the picture that I really wanted, what I should have done is have my smallest bin count observations that are at least 5, but less than, I don't know, 15, let's say. Say you wanted your smallest bin to contain observations that are at least 5 but less than 15. Well, if you're doing this by hand, you'd have to redraw the whole thing, recount everything out. But if you're doing this on your calculator, maybe you just go back to window, here's the window key, and you say, oh, my X minimum, the left endpoint of my smallest bin, instead of being 0, it should be 5. Because now we want our smallest bin to go from 5 to 15. Note that if it goes from 5 to 15, the smallest bin, then my next bin would go 15 to 25, then 25 to 35, 35 to 45, 45 to 55 if I want to include this observation. So if I went from 5 to 15, my X max would now be 55. My X scale is still 10. The width of those bins are still 10. From 5 to 15 is a distance of 10. So that would stay the same. My Y min is 0. My Y max, you can try it with 6. Although I think what will happen is you'll end up with more than 6 observations in your smallest bin. So if you try it with 6, what you'll see is the top of some of the bins get cut off and you can't see the whole thing. Here, I'll show you. If you try it, like you can't see the top of that bin. You don't know how high it is. Yeah, you could use the trace function to figure it out, to figure out how high it is. But maybe what would have been a better idea is to go back to window and change my Y max to something a little bit bigger. As I mentioned before, 10 is always sufficient for Y max. If you try a Y max of 10 and hit graph, now you get to see a histogram, and it looks like this. Note that my smallest bin goes from 5 to 15. Here's 10 right here, here's 5, and here's 15. Don't believe me? Hit the trace key. Smallest bin goes from 5 to 15, and there's 9 such observations. So one advantage of doing it on your calculator is if you ever have to redo it, if you ever have to make several of these, which it turns out in practice you do, you can change them really quickly rather than redrawing the whole thing. There's histograms, making them on your calculator. That's all I got for this video.